Hi, and welcome back to Low Level Devil channel's OS development using the Linux kernel series. If you haven't seen the previous videos in this series, there's a link to the playlist in the comments. In the previous video, we covered how memory was allocated using syscalls in the kernel. In a few videos, I want to start showing how to change the resolution of the screen and start writing to the video buffer, but first we need to cover a few more essential topics. In this video, we'll cover asynchronous I/O and reading input events. So let's get started. We're going to need to start with a new syscall, which is called select. So if I open up the table here, let's find it, we have select is our syscall. And it takes in several parameters, a number, and fdsets, which are file descriptor sets, and then a timeout variable. Let's go to the man pages and we'll look at it in more depth here. So here's the values it uses. The first two are the most important that we're going to care about. We have the set that it's reading and then the highest number set. Now this NFDS, we look for it down here, this argument should be set to the highest numbered file descriptor in any of the three sets, plus 1. So it's very specific on what you need to put for the input, and so we'll cover that when we get into the code on invoking it more. For now, we're just going to, it returns an int value, and we'll create our system call. Just copy these values right in, paste them here, and that's our syscall. We have some includes we're going to need to also add for these fdset variables. I'm just going to add them in the include file. Actually, it's just one that we need. We need sys/select.h. So that should take care of these undefined types. And now for the implementation, actually let me paste it in here first. We'll add an external value for it. And for the implementation, simply just need to return the syscall with sys_select and pass in all the variables in order: nfds, readfs, the write fds, accept fds, and the timeout, and then 0 for the last parameter. So the syscall is how you actually do the sysselect call is how you actually do asynchronous selecting. Now the util functions, I want to add a few more utility functions that I'm going to need to use in here. First one is for allocating the memory at a certain size. We're going to start by getting the current break. If you remember from the previous video, we just call sysbreak with a 0 parameter, and that gets us where the current system break is. Oops, I spelled unsigned wrong here. So now, if you remember, Linux allocates in page sizes. So and it's a 4K page size. So let's get the number of pages that are required to allocate for that size. And we'll say that the actual size is going to be num pages plus 1 times 4096. So we'll allocate it in chunks of 4K pages. Now we're just going to call sysbreak with the current position. We need to do some casting here. So the current break plus the size, and we'll return the current break. It's not curl, it's current break. Now another couple functions. We'll have a memcopy and a memset function. So the mem set is just like the standard C mem set, where you want to set all the bytes in a pointer to a certain value. And again, the point of this course isn't to show you how to do things the most efficient way, or or the best for a certain architecture. So these are really simple implementations. I'm not going to do a ton of error checking and all that, because that's just not the point of this course. I'll assume that you're good C programmers and you know how to write your own, or even if you don't want to use libc, you want to create your own, then you'll know how to do it the best way. So mem copy, we're just going to copy from the source to the destination, just like mem copy. I'll just change these to char pointers so I can iterate through each byte. And for each value up to size, I'll just say destination I equals source I. Really simple implementation. And I'll create a simple string copy too, since we have mem copy. Let's take that one. Dest and source. And this will just call mem copy dest source, and it will use the string length of the source +1, because we want that null terminator in there as well. Right now we'll put those in our header so we can use them in other programs. Right. And we'd want to make them external too, so I'm going to put the extern and copy it to the beginning of all these. And that should be it for the mylib file. Now in our lash, we're going to do some updates to this to start using this sysselect to read asynchronous output. First, we're going to need to create a couple structures. We'll add these at the top. We have an event file, which is going to be a linked list. If you're not familiar with linked lists, you might want to look them up, but it's a simple way to create a dynamic list in C. So each of these is going to have a file descriptor and a name. Now this name is going to correspond to, if you go to dev/input/event star, these are all the input events that Linux receives. Remember, everything in Linux is a file, so whenever an event happens, it's piped to one of these event files. So what we need to do is synchronously read these files to process the events. So we're going to create a linked list of those files. And first, let's actually load that linked list. We'll create a function called load event devices, and we'll create a global list. This is going to be the head. We'll call it list head, or actually let's call it event list head. So the first thing we want to do is initialize this and set it to null. So right now there are no events in the list. Remember, this is the file list, so one for each of the event files. So now let's go from I to 10. We'll just use a max number of 10. It likely shouldn't be that many on your system. So first we're going to create a name here. We'll use sprintf. That's in our printf.h file. So we're going to do dev input event %d and then I. So we're going to go from 0 to 10 and we'll stop when we don't find one of them. So fd equals sys open that name in read only. Okay, now if that file descriptor is less than 0, then we know it didn't find it, and we can just break out of the loop. So not found. So if it did find it, we want to create a new event file object. And we'll use our memAlloc function. And the size we want to alloc is the size of the struct event file. And now we're going to want to use stir copy. We want to copy that name into the event file's name. So ename to name. Then we'll want to set the file descriptor to the fd that we just opened, and set the next pointer to the current event list head. Now we want to reset the event list head to this new one we created. Whenever we create one, it's going to be at the top of the event list, which is useful for when we call select. Now let's create, actually let's copy this load event devices function. We want to make sure we call that right at the start of the program. So we'll call it right after console.open, or console open. Let's move this after that. Alright, so now we're loading the input devices at the very start. Now that we've loaded the input devices, we need to start asynchronously reading them using the sysselect. So we'll create a new function here called handle events. Okay, so to start with, we're just going to print out listening for events. Now we're just going to loop infinitely reading on these events. So we'll start with an fdset, we'll call it fds. And the first thing you need to do with an fdset is call fd0 to zero it out. Now we'll take a struct event file, e is equal to our list head. And this is how you iterate through a linked list if you aren't aware. So you start at the head. Now what we want to do is add that fd to the fdset. And now we do e equals e next. So we essentially are looping through each item in the list. So now we're going to make our syscall. So on sysselect, we want to pass in the event list head fd plus 1. Event list head fd plus 1. Now you remember that's where it said in our select this nfds. Where's it at here? Yeah, nfds. It explicitly said you need to set it to the highest value plus 1, and since we're start using our list head as the latest one, we just add plus 1 to its file descriptor. Then we pass in the file descriptors to read, and then null for everything else. Now if it returns 0, there was some serious error, so this technically shouldn't happen, but you know, things can go wrong. So we'll just print out and return if that happens. So if it didn't happen, then we know that there was an event that could have happened. So what we want to do is, again, iterate through each of our event files and find out, you know, if that event file had an event happen on it. So to do that, we'll call fd is set, pass in this event file's file descriptor. So that would mean that there was an event that happened on this file's file descriptor. So now we should be able to read for that event. And we'll also say E equals E next so we don't forget it later. So to start with, what we want to do is create a buffer. I'm going to do a 1K buffer. And we're going to call sysread with on the file descriptor, pass in that buffer and the size of the buffer. So the size of the buffer is 1024. It's likely not going to be anywhere near that. The value we care about is that R value, how many bytes it actually read. So we'll start with a position 0 of the buffer, and what we're going to do is loop through each value that's returned. So while the position is less than the amount of bytes read, we're going to say the input event, call it event, equals, and we're going to cast it to an input event, the value of at buffer plus position. So this input event, actually we need to include a header file here for this. Input event is in the Linux input event codes.h header. You'll see there. I'll post a link to this site in the comments as well. This has the definition of that input event structure. It's got a time interval, the type, the code, and the value on that event. So when you read on these event files, it's going to return you one or more of those events. So input event, back to here. So now we have one, we're going to pause plus position plus equals the size of the event object. Is it saying it can't find that? So let's just try struct input event. So we'll say size of struct input event. And it's still not liking that. Let's look here at this file. It's included there. It looks like that might be just defines, but we'll start writing our print statement. So when we get one, we're just going to print out the data for it. Input, we'll do the name, the type, the code, and the value. So ename, that's the file that we pulled it from. Event. Okay, it's not finding value. You know what, let's just go ahead and create a copy of that ourselves. We just copy this from here and put it up at the top of our file. Now, because that event codes, it looks like that's just a listing of the actual values, not the structure itself. So just make it easy and copy it ourselves. So we want the code, the type, and the value. We don't care about that timestamp really. Alright, so now we're going to iterate through each of them. That should be enough to at least show what happens when we start reading from these devices. And we can have a stop point. So if the events, I think it's in value, if the value is equal to the key end, then we can just return from this and stop processing. So now we want to invoke that handle events, and to do that we're just going to use that process command function that we created for several other commands. So stir eq command, we'll call it events. So if they type events, we're going to start this handle events function. Okay, I think that's enough. Let's go and build it. We need to start with the mylib. Make that, make install, and go back to lash, make that, make install, and now let's just reboot and see what this looks like. So I'm going to select my OS. Alright, so we can see it's initializing. I'm going to drag it and make it a little bigger. Alright, so let's type events. Now you can see all kind of output on the screen here, as it's asynchronously reading everything that I do. I hold down a key and I got data flying by, and all these are from the event1 file. And I can also move my mouse. So right now I'm moving my mouse around. You can't really see it, but you see all these negative and positive numbers at the end. That's the delta that the mouse is moving. Now I can hold down some keys. I'm trying the end and it's not working. So maybe it's a different way you do that. So when we go back, we'll improve on this a little bit and actually show mouse coordinates. So booting back into our program, what I'm going to start with is creating a mouse structure so we can track where the mouse position is, since we're really just getting the delta from the events. Yeah, let's see, event value is what I was using for that. That doesn't work. I think it's probably going to be code or something like that. Okay, so let's open back up Firefox. And again, I'll put this URL in the comments as well. What we want to start with here is the event types, evrel. So this is used to describe the relative access value changes, moving the mouse 5 units to the left, so you're going to get a value 5. You're not going to get the position of the mouse, you get that value. So event key is going to be different key combinations. So let's start with creating a structure for the mouse here. And we will call it mouse position info. So what do we want about the mouse position? We want the X and the Y, and then a max value for X and Y. So once we start setting screen resolutions, we're going to be able to set what that correct value is. For now, we're going to create a mouse pause global object, and when we initialize our devices, we're going to set our X to 0, our Y to 0, and then we'll set our default resolution to 1024 by 768. And this isn't changing the resolution, this is just going to be what we're going to assume their resolution is. Alright, so now let's go in here, and we're going to create a function called handle event. I think that'll be the cleanest way to do this. We'll take that. So we'll create a new function, handle event. It's going to take in the struct event file, so the file that the event came from, and the struct, what is it called? Input event. So that the actual event. Let me just paste this back in here. And so we want to pass E and event. Alright, clean this up. So first we want to see if the event code, if that is evrel. If it's evrel, we know it came from the mouse. It's going to be one of the move positions, moving in the XY axis. So then when we want to see if the type is rel x, then we know it's moved in the x direction. So if it did move in the x direction, we're going to grab the new x is going to be the mouse pause x plus the event value, because that's where the actual value is stored. The plus or minus 2, 5, 20, however fast you move the mouse. We'll do a little bit of balance checking to make sure that that new x is greater than 0, greater than or equal to 0, or less than or equal to our max value. And if so, we'll set the mouse position to that new value. And we're going to do the same thing with the y value. And tracking your mouse is pretty much the first step that you need to do when creating a UI, because if you don't know where your mouse is, you can't really do too much with the UI. Okay, so now the other thing we want to do, well, first we'll print this out, and we're going to use /r. That's going to return the cursor to the beginning of the line, so that we're not just, spamming the console with a ton of stuff. We're just going to go back to the beginning of the line, print out the mouse pause, put a bunch of spaces after it, so we write over bigger numbers with smaller numbers. You'll see what I mean in a minute. So we'll put the mouse pause X and mouse pause Y. And we're not putting a return at the end, notice that. Alright, so event code equals EV key, then we know it came from the keyboard. And we can put all this stuff in here. And event value didn't work, so we'll try type. Maybe it's type. And I'm not sure if I have those backwards or not. So we'll say exiting if they hit that enter key. Let's change this to a bool, because if they're exiting, we want to return true. Otherwise, it's always just going to return false. That way, inside of our function, we can say if handle events. If that returns true, then we know we need to return and break out of that infinite while loop. Okay, now we should be ready to build again. Call make, sudo make install. And yeah, actually let me go back here. I did mix these up. This type should be code, and that code should be type. So the event type is going to be evrel, and the event code is going to be relx. I had that wrong. So we'll rebuild that and make install again. Now we should be able to reboot and see what this looks like. Let's see. Alright, go to my OS. Okay, it's booting up. So now if I type, actually let me make this bigger so you can see it. Hit enter. So if I type events, now you can see a bunch of events. Now I'm moving my mouse around. You notice that it's just showing at the bottom the new mouse coordinates. It's a little cleaner looking than spamming one line out for every move. So I got it. Now if I start typing keys, A, B, C, and just pressing keys here, you'll see at the end there's zeros and 1. 0 means you let go, 1 means you pressed, 2 means it's a repeat. So now I hit my end key and that worked. And now I can just go ahead and reboot. Okay, so there you have it. Receiving and handling input events asynchronously. So now our Linux-based OS can support reading from input asynchronously and allocating memory dynamically. Our memory allocation is still very primitive since it doesn't support deallocation yet, or chunking allocations into several smaller units per page. But for now that's enough for our demonstration purposes. So in the next video, I think we can start playing around with changing video modes using DRM and KMS. I hope you enjoyed this video. If you did, please like, comment, subscribe, all that, and thanks for watching.